Hello world and welcome to this edition of Tech on Fire with Blaze. I'm Blaze Stewart, architect at Atmosera, and today we're going to be taking a look at the different offerings for SQL databases on Azure. Hi guys, today we're going to be taking a look at Azure SQL, and we're going to be looking at the myriad of options available for running SQL databases on Azure. There's a lot of these that have intended use cases and specific kinds of workloads in mind, but fundamentally they're all running SQL databases on Azure in some way. So let's just dive right in and talk about these from a high level. We'll just go through each option and talk about the use cases for each one. So there's two basic flavors for provisioned compute on Azure for SQL databases, and that's the DTU model and the vCore model. And the DTU model is the more traditional of the two, and it's been around for a while. It's basically a combination of CPU, memory, and IOPS that's rolled up into a unit that is basically a data transfer unit, and that unit can then be scaled individually to add more capacity to your database. So if you need to scale up memory or compute or IOPS on your database within the tier, you just simply add more DTUs to your database. Now that basically gives you one slider that you can use to adjust the performance characteristics of your database. If you need more CPU, you have to increase the amount of memory that you're using as well as the IOPS that you're using at the same time. So they're not independently scalable within that context. However, it is a very simple model, and it is one that is easy to use. If you're not familiar with the performance characteristics of your database, this might be a good option. But generally speaking, more and more folks are going more to the vCore model, which is the other one, because it gives you more control over the compute characteristics of the database. You basically can select the generation of the kind of hardware you want to run your SQL database on. Then you tell it the number of cores you want to assign to that database. And it can range from 1 up to about 40 cores for a given database. And then you can also choose between the different hardware levels, and that will also determine how much memory your database is going to get on a per core basis as well. So you can have options for that scalability within the context of this model. Now, this one is the standard offering that is generally preferred nowadays. So if you're not really sure that you want to use the DTU model, probably just default to the vCore model and just go with that one. And it's probably going to work for most of your use cases. There's some other options that we're going to talk about within the vCore and DTU models that are more of subsets of these, but these are the two high-level offerings, and we're going to drill down into each one of these in just a little bit. So this table basically summarizes the DTU offerings. You have a basic tier, you have a standard tier, and a premium tier, and there is some scalability within each of these tiers. They all have the basic same SLA of 4 nines and different database capacities at 2 gigabytes, 1 terabyte, 4 terabytes, but they have different thresholds on their IOPS and the maximum number of DTUs that can be assigned to it. The basic one obviously is going to be for small workloads, and this is generally intended for dev type workloads that don't require a lot of DTUs or CPU intense operations in the database. Now, the standard and premium tier are the ones that are going to be used for production oriented workloads, and they can provision up to 3,000 and 4,000 respectively. However, the premium tier does get more IOPS per DTU, so this is going to be for more in IO intense workloads, while this one is used for more general purpose workloads. So the Azure vCore model has a lot more control over the tunability of the performance characteristics of the database. As we mentioned, the compute scales around the number of cores that you assign to the database. Now, the memory that it gets assigned to your database is a function of the kind of compute that you choose. So if you choose a certain series of VMs, such as the D series, you have a 1 to 3.5 gigabyte ratio for RAM. So if you choose 2 cores, you would get 7 gigabytes of RAM for your database. On, I think, the F series, you get 7 gigabytes of RAM for 1 core. So that basically means that if you chose 2 cores, you would get 14 gigabytes of RAM for your database. So depending on how many cores you select within the context of the kind of compute that you choose, depends on how much RAM will be assigned to your database. Now, outside of that, you also have the kind of throughput that you're going to have for the underlying storage, as well as the SLAs that are going to be available to your database. Now, the two standard offerings on the vCore model are general purpose and business critical, and the differentiator between these is going to be the SLA and the throughput for the storage. So the SLA for general purpose is 4 nines, and then for business critical is 4.5 nines. So it's almost an order of magnitude difference between the SLA between these two. So if you need that extra availability, then you might want to choose business critical, but 4 nines is still really good for any database offering on a cloud service. Now, the other biggest difference between these is the throughput on the underlying storage. And the general purpose uses a lower tier storage option on Azure. So you get to about 10 milliseconds, 5 to 10 milliseconds for reads and writes on that storage, while business critical gets between 1 to 2 milliseconds on reads and writes. So that is going to greatly impact the ability to do a lot of small operations on your database. So the business critical tier would be great for applications that have a lot of IO intense operations going on in the database. So a lot of small transactions might be a good thing to use for business critical. While if you're just doing more general reads and writes, then general purpose might be a good option for that case. Now, as far as replica goes, the general purpose just has a single replica, while the business critical option has 3 replicas, and you can scale that out to a read-only replica if you need it for read-intense applications, so that you can have more reads than available than writes in this particular instance. Now, the hyperscale option, which I haven't talked about, is a completely different use case, and that's mainly because this one is oriented around the kind of database that this is used for. This is for big data. So the hyperscale option is intended to partition data across multiple compute nodes like you would expect in an HPC setup or high performance compute setup. Basically, you have large chunks of data that get partitioned across multiple compute nodes and multiple storage nodes. So basically you have the ability to create parallel jobs across a compute cluster, and it's going to be operating on all of those different jobs in parallel, and then it's going to bring all those results back together, then be able to aggregate things and do things like that, which are typically more characteristic of big data type workloads rather than something that's more transaction oriented like you would get with general purpose or business critical tiers on the vCore model right here. So this one has a 4.9 SLA, so it's not as good as the business critical, but this one is also different in the fact that it's using more of a clustering model, that you have compute clusters that are partitioning the data rather than just replicas of the data and a set of dedicated resources like you get with these right here. And this one has distributed storage, so the throughput characteristics are going to wildly vary depending on the kind of operation that you're going to be doing against a hyperscale database. It's a distributed database, so it can be slow in some cases depending on the kind of query, and it can be very fast depending on the other types of queries and the concurrency and a lot of other factors that go into the hyperscale option. And this one is also highly scalable. That's why it's called hyperscale. So you get multiple zone redundancy across a given Azure region with the hyperscale option. So there are any number of given replicas in this given option that you can use for your data storage needs as well as your compute needs as well. So again, the variables on this one are going to be around the size of the data as well as how many zones and what kind of workloads you're going to be throwing at it. And that's going to really determine the performance characteristics, while these are going to be more contingent upon the underlying hardware that you throw at it, while business critical is going to have faster disk and typically going to be able to recall data and write data faster than the general purpose because it's using slower hardware than what you would get with the business critical tier. So the serverless option on Azure SQL is an extension of the vCore model, and it basically allows you to set up an option for your database that only allocates compute when it's needed, and whenever the compute is idle for a specific amount of time, it shuts the compute down and you won't be billed for it. So this is a great option for databases that have bursty type workloads, or maybe they're only active for a certain period of the day. So you run a bunch of jobs between 3 and 4 o'clock, and the rest of the time the database is idle. So this is a great option for whenever your use cases are something like that. So the typical use case, like for vCores or even DTUs, is where you basically allocate an amount of compute and you pay for that full compute whether it's idle or not. So that's going to basically fill up every piece under this, which is going to be the build time for that compute, whether it's used or not. The serverless model only bills for what you actually use. So that would be everything under this particular curve right here would be the time that you're going to be billed for. So the number of cores times the amount of time is basically what you end up with for the serverless option, instead of paying full capacity if you were going to reserve that same amount of capacity for a full-time database, whether you use that capacity or not. So another option with some variability in the compute like serverless is the elastic pools model. Now this one follows the DTU model, which has a capacity of compute, memory, and IOPS assigned to a given unit. Now a DTU is assigned to a single database, while eDTUs allows you to create a pool of compute resources and assign a bunch of databases to that pool. So all of these DTUs will be shared across all of these databases here. Now you can reserve a given capacity for a single database, but ultimately it's going to be shared across all of the databases in my given elastic pool that I'm going to be setting up here. Now this is useful for a bunch of databases that have low utilization patterns, but together they will create a more normal usage pattern that you might expect from a highly utilized database. So together they're going to have compute that is going to be consistent across all of the databases for a period of time, but by themselves wouldn't justify having a set of dedicated resources. So with an elastic pool, you can assign all those to that eDTU pool and then have billing against those eDTUs rather than having each one of those databases have its own separate billing model. Now the last two options have to do with compatibility on Azure. The first of these is a managed instance. Now managed instances are designed to provide something that's more akin to a VM, but instead of having to manage the VM, it's managed for you. So this is still technically platform as a service, but it has better compatibility with existing SQL databases that might be migrating from on-premises up to Azure. So you can spin up a managed instance and run things like manage code inside the context of a managed instance that you wouldn't be able to do on something like an Azure SQL database. Now, as far as the model of compute goes, it follows the vCore model, and the vCore model in this case allows you to assign a certain number of compute to the given instance that you might have, and then you can also choose between general purpose and business critical on a managed instance as well. The last option I'm going to mention is an Azure SQL VM. Now, an Azure SQL VM is different from just spinning up a virtual machine and installing SQL Server on it. These are pre-built images from Microsoft that already have SQL Server installed on them. They also have some integration with the Azure portal. They give you some metrics and management through the Azure portal, so you don't have to log into the VM to do those kinds of things that you would otherwise have to do if you just installed it yourself. Now, this one is going to have the highest degree of compatibility for databases that you might be migrating from on-premises into Azure. So if there's some reason that it won't run in Azure SQL or on a SQL managed instance, you can go with a SQL VM and you'll have the ability to run it like you did on premises, except run it on Azure. And of course, the compute characteristics and the storage characteristics are solely dependent upon the kind of compute and the kind of storage that you assign to the VM. So if you choose higher ratios of memory per cores, or you have more cores per and less memory, depends on the kind of workload that you're going to be assigning to your VM for your database. And then also the performance on the storage could be something like standard HDDs, SSDs, premium SSDs, or ultra SSDs, which are going to have different levels of IOPS on there and different levels of throughput for reads and writes on your database. So all of those considerations come into effect whenever you choose the underlying virtual machine for your Azure SQL VM. So we just walked through the offerings for running SQL databases on Azure. And again, there's a lot to choose from. Now, choosing which one is going to work best for you, it just depends on your use cases, but hopefully this will give you some context of which one you might want to choose for running your databases on Azure. If you like this content, please consider checking us out online at www.winelec.com, where you can find several blog entries about topics related to Microsoft Azure and software development. And you can also subscribe to this channel by clicking the subscribe button below and then clicking on the bell icon to receive notifications when new content becomes available. Until next time, thanks.